Let us take a quick recap of what we have done so far. You have been taught about charged particles, two types of charged particles, positive and negative. And it is considered that electron and proton are charge carriers. Electron carry negative charge and proton carry positive charge. Now, when we say that a particular material or a substance is a good conductor of electricity, it means that the conductor has enough number of free electrons, and therefore the presence of free electrons makes a conductor a good conductor of electricity. Now, when these free electrons flow in a particular direction across the conductor, then it constitutes electric current. So, electric current is the flow of electric charges in a conductor, and the formula is given by Q upon T. The SI unit of current is ampere, and it is a scalar quantity. Also, it has been told to you that there are two types of currents. One is conventional current and the other one is electronic current. Conventional current is the current that we assume to travel from, or it is assumed to be moving from positive end of the cell or a battery to the negative end in the external circuit. But actually the flow of electron is just the opposite. That means electronic current is opposite, the direction of electronic current is opposite to the direction of conventional current. And cell and a battery is a source of current. However, electric current in a circuit flows only from high potential to low potential, and this should be maintained. The difference in the potentials should be maintained if we want the current to flow through a circuit or through a wire or any electrical components. The formula for potential difference is W upon Q, where W is the work done by the charge in moving from one point to another in an electric field. The SI unit of potential difference as well as electric potential is volt, and it is also a scalar quantity.
Today we will study about electric circuits and circuit diagram. All electrical components or appliances are joined or are connected with each other in a certain manner. A continuous path consisting of conducting wires and other electrical appliances between the terminals of a battery or a cell along which an electric current flows is known as electric circuit. Electrical circuits are represented by drawing circuit diagrams. A circuit diagram is a diagram which indicates how different electrical components in a circuit have been connected by using electrical symbols for that component. For an electrical circuit to be complete, each component of it must pass current through it. That is, it should be conducting. If there is an insulator in the path or the circuit is broken, then the circuit is incomplete or it is said to be an open circuit and the current will not flow through it.
Let us now understand how to design a circuit in this virtual lab. So first I will show you how to join or how to connect cells in series. The electrical components which are joined one after the another are said to be in series. Now I have taken one cell. This is not a battery, this is a cell because it has one positive terminal and one negative terminal. So this is a cell. This is the electrical symbol of the cell. The long vertical line is positive terminal and the short one is the negative terminal. I have one voltmeter here. This is a digital voltmeter. The red end of the voltmeter or the red terminal of the voltmeter should always be connected to the positive end of the cell. That means at the higher potential. This end of the voltmeter should be at the higher potential and therefore connected to the positive end, while the black end should be at the lower, should be connected to the lower potential of the cell, which is the negative. And here you can read that the voltage or the potential difference across this cell is 9 volts. So now I have removed the connections with this voltmeter. This is a digital voltmeter. Now since cells to be joined in series, so series means one after the another. So this is the positive terminal, this is the negative terminal, and now I will join them like this. So these are two cells in series, and now this has become a battery. If I bring another cell and join in this way, so this is a battery consisting of 3 cells. The symbolic representation would be like this. Now if I measure the voltage across each cell, it will come out to be 9 volts. So this is the negative end and this is the positive end of the first battery. It is showing 9 volt, right? But if I join the positive end of this battery with the red end of the voltmeter, then you can easily see that it is now 18 volts because these two have been joined in series. On connecting the red terminal to the third cell, then it is now 3 times of the previous one. So this is how it is. And this is how the cells are joined in series. So we can join as many cells we want to, and the same changes in the voltage will take place. One more thing that I would like to show you here right now is that if I reverse the connections, then let's see what happens. So now I have connected the negative, the positive end of the cell with the black terminal, and let me now join the red terminal of this voltmeter to the negative end and see what happens. The magnitude, that means the number which it's showing, is 9 volts, but there is a negative sign just because the connections are done in reverse. The second task is to make a simple circuit using a light bulb and a switch. So let's see how connections are done. So I will require one cell, one light bulb, a switch, and connecting wires. Let's see what are the symbol of these components, electrical components. And this is how we represent, now you know very well, this is the cell. This is how we represent a switch, a connecting wire with simply a straight line, and this is the symbol of the bulb. And all of them needs to be joined in a proper way so that the circuit functions. So these are the actual images of the electrical components. Let us join now. So I have taken a wire. Let me join the wire with this end of the bulb. I will require now one more wire, and this is how I will connect it with the cell. So right now the circuit is open because the switch is not closed. The circuit is broken, or we can say the circuit is open. So there is no current flowing through it. Now once the circuit will be closed, then there will be current flowing across it, provided I have joined them in a proper way. So let me join the circuit. That means let me now close the circuit. And see, it is working. The bulb is glowing and the direction of electron flow, you can see clearly, is shown, and it is flowing through the wire. This bulb is also called load. In fact, any electrical appliance is called load because it uses electricity for its functioning. So whether it is a bulb or a heater or washing machine, television, refrigerator, all these appliances are termed as load. So this is how we join the circuit. Now let us experiment a little bit more on this, and let's see what is the voltage across the bulb. Now I have shown you already that this cell is of voltage 9 volts. So let me check once again that right now when there is a current flowing across the cell, whether this is also 9 volts or not. So yes, it is 9 volts. Okay, so let me join the same voltmeter with the bulb. So the two ends with the across the two terminals of the bulb, and it is showing that it is 9 volts. Voltmeter always needs to be joined in parallel, and the connections which I have shown you are parallel connection. That means one end of the voltmeter is joined at the one terminal of the bulb, and the other end is connected to the second end of the bulb. Now this end of the bulb is joined with the positive end of the terminal, positive end of the cell. So this becomes positive end of the bulb, and this one is the negative end of the bulb. And therefore the black terminal of the voltmeter is joined with the negative terminal, while the positive end, sorry, the red end of the voltmeter is connected to the positive end of the bulb. So it is 9 volts. Now, if I want to see how much current flows through this circuit, then I will put a ammeter here. Now, this is again a digital ammeter that we are using in this virtual lab. So, this digital ammeter should be connected in series with the circuit. So I have told you already, series means one after the another. So I will remove this wire, and instead of this connecting wire, I'll put one ammeter here. So let's see how much current flows across it. So let me first of all open the circuit so that the current stops flowing, and then I will replace this wire with the ammeter. So let me join the connections once again, and the current which is now flowing through the bulb is 0.9 ampere. 9 volt cell is right now providing a current of 0.9 ampere, and the bulb is glowing. Now if I reverse the terminals of this cell, so let's see whether the bulb will glow with the same brightness or not. So I have now reversed the terminals, and now you can see the positive end is this side and the negative end has gone the other side. And the current is flowing, the bulb is also glowing with the same brightness, only the direction of current is reversed now. The flow of electrons, which is the actual current, is now reversed. So this is the direction of electrons when the cell is connected in this way. And if I show you the direction of conventional current, so it is just the opposite. This direction we show in books and in all the circuit diagrams, but actually the flow of electrons is just the reverse. In the same circuit now, if I put an eraser or a graphite pencil, then whether this circuit will function or not, let us see that also. So for the time being, I am opening the circuit like in this way, and I don't require a voltmeter now, in fact. So let me I will remove this wire from here, and instead of this wire, I will put one eraser. And now if I join the circuit, what do you observe? There is no current flowing in the circuit. Why? Because this eraser uh, is an insulator. So definitely there will be no current flowing through the circuit. This is an incomplete circuit, right? But if I connect with this pin, then let's see whether the bulb will glow or not. Yes, it is glowing. And you can see the current is the same. And why? Because this paper clip are the paper clips are generally made up of metals, and metals are good conductors of electricity. So let me remove this, and now let me place one graphite pencil. Okay, yes, this is a pencil. So let me join. Graphite is nothing but carbon, and it was taught to you that carbon is the only non-metal which is a good conductor of electricity. So when this circuit is joined with a pencil, graphite pencil, then whether this will function or not, this we have to see. And yes, it is functioning. The bulb is glowing, but with lesser brightness, just because being a non-metal, carbon conducts electricity, but it offers high resistance also. That means it obstructs the flow of electrons, right? So this is what is the simple circuit all about. And I hope you have understood that in order to join or make the connections, what are the things that we need. So basically, we need a source of supply, which is a cell. This can be a battery also. We need connecting wires and the load. So load over here is a bulb right now. If we want to measure current, then the ammeter to be put up in series with the circuit. And if we want to measure the potential difference or the voltage, then this should be connected in parallel with the circuit or the electrical component across which we want to measure the voltage. In the next task, I'll use the same components. That means a light bulb, one cell, wire, and a switch. But now if I add in a second cell, then let's see what happens to the light bulb. So this is the first cell, and the voltage across the first cell is 9 volts as shown to you earlier. So if I now take the second cell and if I join them in series, then it will become a battery. But let me first of all join the simple circuit using the light bulb, connecting wires, and a switch. So let me join the way I had joined it earlier. So this is it, and this is another wire, and the circuit is complete. So it is the simple circuit which I had shown you just now. So if I close the switch, the bulb will glow. Now the task is that if I now add the second cell over here so that it becomes now a battery, then what changes do we observe in the bulb? So let me do it in this way. Yes. So these are two cells in series, and therefore it is a battery. If I measure the voltage across each cell, so it was 9 volts, but if I measure voltage across this battery consisting of 2 cells, then it becomes 18 volts, twice the previous, right? So let me now close the circuit and see the brightness. Is there any change in the brightness of the bulb or not? And see, it is glowing with double the brightness. And we can confirm here that from a voltmeter, by getting this voltmeter connected over here across the two terminals, that the voltage across this bulb is also now 18 volts. When single cell was joined with this bulb, then the voltage I had shown you across the bulb was 9 volts. But then if a battery of 18 volts is joined across this bulb, then this bulb also has the potential difference equal to 18 volt. And since the voltage is doubled, so the brightness of the bulb is also doubled. So now the circuit is open. Next is that if I want to measure the current across this bulb due to the battery of 18 volt, then let's see how much current then flows. So if you remember, when I had joined the previous circuit, the current across the bulb was 0.90 ampere, right? So let's see if the current remains the same or it is now different. So what I'll do, I'll remove this wire, and now let me join the ammeter. This is a digital ammeter, as I have told you already. This is a digital ammeter, and I have to and we have to join the ammeter always in series with the circuit. So this is how we have to join. And on closing the circuit, now see, the current is also doubled. It is 1.80 ampere now. Okay, the voltage across the bulb is also double than the previous value. The current has also become double. The brightness therefore is double. So this is the difference that we have to observe on connecting the bulb with a single cell and when the bulb is connected with a battery. So obviously if I put one more cell here, then the brightness will increase, the current will also increase, as well as the voltage across the bulb will also increase. Therefore, we can conclude that the bigger the voltage, the brighter the light should be.